Hello everyone, we are group 22 and we have designed a script to process a medical question and answer data set. It will generate semantic embeddings for the data set using sentence transformers. It will store the embeddings in a Pinecone vector database for efficient similarity search. The query Pinecone is used to retrieve the most relevant answers for user queries based on semantic similarity. So the code, okay, this is our backend. The code installs the necessary Python packages. So here is the data set, and there are question and answers in our data set. The medical question and answer. We have installed the Pinecone client, and embedding it converts texts into a high dimensional numerical vector, 768 dimensional for our case, which captures the semantic meaning of the text. So here the UUID, unique IDs are imported for vectors. We have set up the Pinecone and provided the API key. When the dataset is loaded, we have the user provides a query, and the absurd batch we have performed for 199 epochs. S-
Yeah, so I'll go ahead with the next part of the code. So here I'll explain about the batches. And so here we have made the 200 batches of each because we have 19,000 rows, and to make the processing very easy. So moving ahead with this, we have this next document, which is calculating the similarity score to match with the questions and answers embedding. So here we have implemented similarity score. So it goes from here, and it will give me the result, or it will give me the percentage how much the embedding is matching from the user query and from the database query from the Pinecone. And and the last step is that we will give the query like how much like how we can reduce the weight. So based on this will give me the response, that will be the answer from our data set. So to get the tips from to how to reduce the weight, we have this simple formula, and to do some exercise and all those stuffs. And then we have this similarity score. So this is our basic question. So whatever the query that we gave to the system, it this one, and it matches with this question because it has the matching similarity score. So however it matches with this will give the exact answer, which is what is in our Pinecone database as an embedding. And here I have shown you the similarity score. So if it is so it's here, it's 76%. So that's why it gave us the answer of that. And I'll go more deeper on the code because I'll show you how we have implemented our data set. It goes through the GitHub, and then we implemented some pre-processing, but at the end step we didn't find anything useful to implement the pre-processing, because in the model we have implemented, because we don't need the pre-processing as because these models are quite equipped without the pre-processing. So we don't need to worry about the stop words, the comma, the punctuation marks, and all those things. So, and this is our Pinecone, and here I have given the API key for the Pinecone, the environment setup, and I'll show you my Pinecone. So here is my Pinecone. This is my environment name and the host and the region, and here it's 36,518 rows. So I'll go ahead with the next part of the code, which is this. So here is my API, and then this is the dimension that I have taken here. And because I'm using here as Alpha MNet base version 2, I previously I took another model, but it was not robust to the stop words and pre-processing. So that's why I have used this model, because this is more good towards stop words, because if we didn't apply any pre-processing, this will handle itself. So this is already described by the Sajiri. And then here we have implemented the batches, because if we didn't implement the batches, it's very difficult to capture the semantic meaning and to convert into the embeddings. So this will give us more time and more efficient way to implement the embeddings. And here I have implemented the Langchain to match with the embeddings, and that's all our backend is, and it successfully runs for every query that we will give to the user by the user. And then I'll show you my main file, which is here, and I'll upload it from here. So in both of the files I have implemented how my streamlit is implemented. So first I'll go ahead with main.py. So here I have implemented my Streamlit code, and I have made the imports here. And here is my Pinecone key, index name, and the dimensions, which I already mentioned in my backend code, which is right here. So this one. And after that, I have implemented the instance of my Pinecone, and this is my model that I have used there. And this is the basic how I'll populate my table, how I'll populate my index, because at initials at Pinecone our indexes is not populated. So this is the basic population. And then after that we have given the title and some basic queries to handle the exceptions. And then at last we have implemented here the how it will match and how it will give us the result. So if the result matches with the query which is in the Pinecone, then it will give us the context, or it will give us the result based on that. And similarly, based on that, we have these UI containers, which goes from our question to the searching stage, and then like it will directly go ahead with the query pinecone. So this function will straight away hit this function, which is here, and this will do the required pre-processing and how it will catch those embeddings which is required. And at last I have this utils files as well, which will handle these functions as well to find the match and to query the refiner and to get the conversions strings. And similarly we have this document. I'll straight away show it to you here. And we have also implemented this. So this is our basic implementation, and I'll show you how the code runs. So it's I'll just write away this code. So my main file is the main.py. So it's streamlit run main.py. So whenever I hit this, so I get to this localhost, and this will take some time. So yeah, it's here. So we are here at this localhost, and we have this link here as well. So that's how our project is working. Thank you. Have a nice day.